Hello, this is Mr. Huber. In this lesson, we're going to look at the standard form of quadratic functions. You can see the standard form for a quadratic function written here is in the form ax squared plus bx plus c. One thing to keep in mind, when we have that squared term as our highest exponent, that's what's called a quadratic function. So quadratic functions have the standard form of ax squared plus bx plus c, where a, b, and c are some numbers. Let's look at what we can do to make sure we know what those values are, because they're going to be important in terms of being able to work with these quadratic functions. All right, in this first function, f of x equals 4x squared plus 11x plus 6, we have an a value of 4, a b value of 11, and a c value of negative 6. The values here, 4ax squared, bx, 11, plus c, so it's a minus 6, so it's plus negative 6. Our c value is negative 6. Okay. No variables here. The a value is not 4x squared, it's the coefficient in front of the x squared. So when we look at the second example, we have f of x equals negative 5x squared plus 9. Our a value is negative 5. Our b value is 0, and our c value is 9. This would be like in the middle here if we had plus 0x. 0x is just 0. We don't have to write it in our equation. But the b value is 0. Don't just take the first number, second number, third number. You have to make sure it's in that standard form. Ax squared plus bx plus c. Look for the coefficient in front of the x squared, in front of the x, and then the constant term for that c value. And so in our third example here, our a value is 3 over 5. It's a fraction, that's fine. Our b value is negative 8, and our c value is 0. It'd be like having a plus 0 on the end here. We don't have to write that. So make sure you can identify the a, b, and c values. We're going to see where those come into play in terms of working with these, in particular graphing them. So just a couple of reminders here, things we've seen with quadratic functions before. They have U-shaped graphs, right, called parabolas. Ax squared plus bx plus c compares to the parent graph by when a is positive. When this number is positive, remember it opens up. It's going to be a parabola opening up. When a is negative, it's a parabola opening down. When the absolute value of a is greater than 1, our parabola is going to get more narrow. When that value is between 0 and 1, okay, then we're going to have a vertical shrink. The graph's going to open up more widely. So if we have a standard y equals x squared, something like this, okay, if our a value is positive, it opens up. This would be an a is greater than 0. Okay? And if we have an a value less than 0, it's going to open down. Okay? That would be if we have an a value that's less than 0, that's negative. Then if we had an a value of like 5 or something like that, okay, so here where we have absolute value a is greater than 1, we'd have a graph that maybe looks something like this, that's more narrow. Okay? And if we had an a value that was between 0 and 1, let's say a was negative 3/5. Okay? A is negative 3/5, it'd be opening down and it'd be more wide than our standard graph. Okay. So those are some things when we see the equation, we have an idea of what the graph might look like. That can help us make sure if we're on the right track, our graph's looking like what we should be expecting to see. Right? Does our answer make sense? These are ways we can look and see if that's becoming the case or not. Let's practice graphing one here. So we've got y equals 3x squared plus 12x minus 1. One of the key things to any parabola is the vertex. That's that point at the top or bottom of the U shape. Right? In order to find that in the axis of symmetry, when we're in standard form, we can use negative b over 2a. That will be the axis of symmetry. X equals negative b over 2a every time. And that will be the x value for the vertex. Remember, the axis of symmetry goes right through the vertex. So the vertex will always have an x-coordinate that is that axis of symmetry x value, negative b over 2a. So we're going to find the axis of symmetry for 3x squared plus 12x minus 1. And we're going to use that to then get a table of values and graph it. So our x value, axis of symmetry, is going to be negative b over 2a. So we have x equals negative 12 over 2a. 2 times 3. That's negative 12 over 6. So that's x equals negative 2. That will be the x value of the vertex. That is the axis of symmetry. Our axis of symmetry then would be it's going to go down through our parabola at negative 2. X equals negative 2. That's our axis of symmetry. We'll see what the parabola looks like around that now, because we can make a table of values where we're going to have negative 2 as our middle value in our table of values, and we're going to have negative 3, negative 4, negative 1, and 0. Right, we get a couple numbers on either side of that x value. Recall that from when we even had vertex form. So now to find the vertex, we're going to take this x equals negative 2, and we're going to plug it into the equation up here. We plug a negative 2 into this equation. And when we do that, we get 3 times negative 2 squared. Don't forget to square the negative 2 properly. Plus 12 times negative 2 minus 1. And if you do that, you're going to get negative 13. Okay, negative 13 for your y value. And you're going to want to go through now and you're going to put in those different x values in for x, and then you're going to be able to complete your table of values. So when you do that, you're going to have a table where on either side of this, we should get the same y values because it should be symmetrical. This is our middle of our graph, and the parabola is going to open up in this case. We have a 3x squared, so it's going to open up. We're going to have a parabola opening up on either side of this axis of symmetry. Okay? And we want to find those other values we're going to get on either side of negative 2 comma negative 13. Okay? Negative 2, negative 13 will be off our graph a little bit here. I could extend this just a little bit. And I get negative 11, negative 12, negative 13. So let's say that's negative 13. So I'm going to have a point at negative 2 comma negative 13, right around there. And now I'm going to want to get my other values. So when I plug these in, again, you plug them in, you make sure you're getting correct numbers here. When you put in negative 1, you get negative 10. When you put in 0, you get negative 1. And same on the other side here, negative 10 and negative 1. Again, you can plug those in, make sure you're getting those same values so that you're going to get proper tables and you can graph these points. And when you do that, you're going to have points that look like this, that then you can draw your parabola through. Again, it's going to be pretty narrow because we have an a value that is an absolute value greater than 1, so it gets more narrow. It's opening up because it's a positive a value, and we've got our graph now drawn for that equation. And the key piece to this is finding this vertex and then getting the points on either side of it. Okay? And we can find the axis of symmetry and the x value for the vertex by doing x equals negative b over 2a, and then going from there. And that vertex is still that key piece to what we're doing. There's another method we can use for graphing these without having to plug all those values in. Sometimes that can be a little bit of an issue. It can take a little bit of time. There could be more mistakes that are made. So we're going to look at a different method here. It'll give us the same graph. We're going to use that same equation, 3x squared plus 12x minus 1. We're going to use something called the 1-3-5 method that uses that symmetry of the parabola. That's the same on both sides of the vertex. And we're going to figure out what's happening on one side and then just copy it over to the other side. And the way this works is when we find the vertex of our graph, we do the negative b over 2a, and we'd get our vertex, just like we did before. So when we do that, we'd have negative 2 comma negative 13. Right, that was our vertex. We do negative b over 2a, get negative 2 for x, plug that in, we get y. We're still going to have to do that to start. We got to find the vertex. Now, from the vertex, we're going to add 1 to the x value times. So negative 2 plus 1 plus 1 plus 1. That's how we get negative 1, 0, and 1. Then from the y value of the vertex, which we got by plugging negative 2 in, comma negative 13, we can then add 1 times a. In this case, remember, a is 3. So this would be plus 1 times 3, plus 3 times 3, plus 5 times 3. And if we see how that worked, our vertex is negative 13. Then we go plus 1 times 3. So we're going to add 3. To go from here to here, we add 3. To go from here to here, we add 3 times 3, which is 9. and from here to here we add 5 times 3, which is 15. So you're always going to add 1, 3, 5 times whatever your a value is. That's why it's called the 1, 3, 5 method. Right? And so if we graph these points now, okay, and we can extend that bottom of the grid just a little bit here and get -11, -12, -13. And at the top we're going to have to extend a little, 11, 12, 13, 14. Okay, it'll be above, just a little bit above there. We can bring this back up and get that 14. We see we're going to have a y value of 14 from what we had there. So now if we graph those points, -2, -13, right around there, -1, -10. Again, these are the same values we had when we made our table the other way. It's not changing what the graph is going to look like. We get these points on one side of the vertex. Okay. Now, on the other side of the vertex, we should have the same points. We saw that it was symmetrical, right? When we plugged in -3, -4, we got the same y values as with -1 and 0. So now we can just mirror that. This point that's right here, it's going to have the same point on the other side of the axis of symmetry. Recall our axis of symmetry going straight down through the middle of the graph. So we can mirror it on the other side, and we'll mark those in red so we can see where it's being mirrored. We're going to have that point right there. Okay, we just took this point and we mirrored it onto the other side. Now we're going to take this point here and we're going to mirror it on the other side. Without plugging in values or anything, we just know it's going to be symmetrical on the other side of the axis of symmetry. And then we're going to have another point right here. And now we could draw our graph that goes through those points. And it will look exactly like the graph we had using the other method where we just made a whole table of values. Okay, and our graph looks the same. So we can get that vertex, and we still have to start with the vertex, -b over 2a, and then you can just plug in points, or you can use the 1, 3, 5 method. Either one works. You're not required to use one or the other. Find which one you think works best for you, practice it, and find out that you can do well at it if you keep going with that same method and you get comfortable with it, because it'll give you the same graph either way. All right, next question. Somewhat math related because there's money involved. But who was the first athlete to be paid a salary of $1 million for any North American team sport? So you think back to all the great baseball, basketball, football players, maybe a hockey player. Okay, who was the first one that got paid $1 million for a single season in any North American team sport? It was in the 70s. If you want to try and take a guess and think who it might be from one of those popular sports, and you'd be wrong because it wasn't from hockey, basketball, baseball, football, but football, if you will, soccer. The great Brazilian star Pelé, he came and played for the New York Cosmos, the North American Soccer League, for $1.4 million for that season in 1975. So soccer great Pelé, the first athlete in North American team sports to break $1 million in salary for a season. Let's see what we can do here with another example for finding the key information for this parabola, for this quadratic equation, the vertex and axis of symmetry, where we always have to start. Then we're going to make sure we go back and remember what it means to have a minimum or a maximum value for the graph and the range of it as well as we draw the graph. So we're going to graph this and be able to answer all those pieces as we go. And we have to start with the vertex. How do we find the vertex? That's that -b over 2a. So x equals -b over 2a. That's our b value is 12 over 2 times -2. So that's x equals -12 over -4. -12 over -4. So that's an x value of 3. So we have an x value of 3. You can either put that 3 here in the middle and then do values on either side of it, 2, 1, 4, and 5, and plug all those in, or you can use the 1, 3, 5 method. I'm going to use the 1, 3, 5 method because I think it's a little newer. It might be one that maybe you could use a little more help reviewing and understanding how to use. If you do a different method here, I would suggest you practice this. Try it with whatever method you think's the one you're going to use, and then we'll see if your method's working or not based on if you're getting the same graph and equation, everything that we are, in the same answers to these key pieces of information. Okay, so again, we're going to do -2x squared plus 12x minus 10. And we do that. Again, we look down here. First start here. Negative b over 2a. So negative 12 over 2 times negative 2. Negative 12 over negative 4, that's a x value of 3. Okay? So now we're going to see what happens when we make our table of values from that. Right? First, we're going to plug in a 3. Okay, we get negative 2. Let's just write it down up here. So we'd have negative 2 times 3 squared plus 12 times 3 minus 10. Okay? And so we'd have negative 2 times 9 is negative 18 plus 36 minus 10. Okay? That's going to be negative 28 plus 36. That's 8. So we get a y value of 8 when we plug in 3. Okay? So now we can do is put that into our table of values. And again, I'm going to change this up a little bit and not do my table this way. But if you are doing it that way, that's fine. With the x value in the middle for the vertex, I'm going to do the 1, 3, 5 method. And so that's going to give us an x value of 3 and a y value of 8. And now from here, I can do 4, 5, and 6. And I'm going to add plus 1 times negative 2. Right, that's plus 1a. Then I'm going to do plus 3 times negative 2. That's 3a. And then I'm going to do plus 5 times negative 2. That's my 5a. So from here, I can get the rest of those values on one side of the parabola, and then I'll be able to see, what it looks like from there. So I get, when I put in a 3, I'd get 8. Then I'd have plus 1 times negative 2, so that's plus negative 2 minus 2. Then it'd be minus 6, and then minus 10. Okay, pretty straightforward. I didn't have to go through, I didn't have to plug numbers in, square them, multiply, do all those things. I added negative 2, negative 6, and negative 10 through my y values. And now I could graph those. So I'm going to get the point 3, 8, right there, 4, 6, 5, 0, and 6, negative 10. So I'm going to have to move this up a little bit so it's not cut off there on the bottom. Yeah, we're going to get 6, negative 10 right here. Okay? And now I've got to mirror those points on the other side of my vertex. Remember my axis of symmetry, okay, goes straight down here through the middle. My axis of symmetry while we're at it is x equals 3. Right? That's my axis of symmetry. There, when my x value of my vertex is the axis of symmetry. The vertex is the point 3, 8. This is the vertex, 3, 8. Right? And I'm going to graph here the rest of this. Get my pen back out instead of the highlighter. And then we'll have a graph that looks like this that I can draw through those points. Put arrows on the ends because it'll keep going. And that's what my graph looks like. We identified the axis of symmetry, the vertex. What's the maximum or minimum value? So the maximum value for this graph, the maximum value is y equals 8. This point up here is the maximum y value. You're not going to get any y values for this graph greater than 8. That is a maximum because it opens down. It's got a high value, a high point, and a maximum of 8. Okay? It's got then, excuse me, a range, okay, of y is less than 8. So the range is y is less than or equal to 8. There's no y values above 8. They're all 8 or something less than that. So you can see from up here, we've answered all those various questions through what we would normally do. To graph this, we got to find the vertex, okay, and axis of symmetry. We got to do the negative b over 2a. That's the axis of symmetry, was x equals 3. The vertex was the point when x is 3, we put it in, get a y value of 8. There's our vertex. The maximum or minimum value, when we graph this, we can see that high point maximum value of y equals 8. The range is y values that are less than or equal to 8. All of our y values are 8 or less than 8. And we can see the graph here, that parabola, by using a table of values, plugging numbers in, or that 1, 3, 5 method. So again, you pick which one you think is going to work best for you and go with it. Let's look at one more. We're not even going to graph it. Just let's talk back about what this means for vertex form. Okay, that was what we looked at previously in terms of how to work with quadratic functions. Let's see how this standard form can help us with vertex form and how they're related. So if we're going to find vertex form, we've got to find the vertex. That's x equals negative b over 2a. That's negative 10 over 4. Okay, so then you're going to get that's fine if you're going to get a decimal. So we're going to have negative 2.5. So now to find the y value of the vertex, we're going to have to do y equals 2 times 2.5 squared. Right? So 2 times 2.5 squared plus 10 times 2.5. And let's try that out here. Plus 7, excuse me. 10 times 2.5 and then plus 7. And we're going to get a y value of 44.5. So 2 times 2.5 squared plus 10 times 2.5 plus 7. And so that means we're going to have a vertex of negative 2.5, comma 44.5. How can we write that into vertex form? Okay, well that's going to be a little different from what we see here. This is standard form, right? This equation here is standard form. If you recall from vertex form, that's the y equals a and then parentheses x minus h squared plus k. So now we can take the h and k values we have there from our vertex and we can put them into vertex form. So we're going to have vertex form is y equals, the a value is still 2, x minus h. So minus negative 2.5 would be plus 2.5 squared, and then plus 44.5. So this gives us vertex form, okay? We take the h value and the k value for our vertex and we plug them in. And we should have had a negative 2.5 and negative 2.5 here. So if we change those, because that's not going to work with positive 2.5, how would I have known that didn't work and look right? We want to know what would happen there, right? When I got that 44.5 and negative 2.5, comma 44.5, I could graph it. I could look and see some numbers on either side of that, and I noticed something didn't look right. So we want to be able to check, why does my answer not look right? Does it make sense? Okay, that 44.5 doesn't make sense. I can go back and figure out that I didn't put in my negative sign here and here. So when I do that, now I'm going to get a different value for my y value. So we can go back and fix it. Again, you have to ask yourself, does my answer make sense? Okay, if it doesn't make sense, let's figure out why so we can fix it. Because otherwise, if you just go with whatever the calculator tells you, then you're going to think you're always right when you might get values that in fact don't work out. So now if we put that in as negative 2.5, we're going to get a y value for the vertex of, check that out and try it again here, you should get negative 5.5. Okay, that is a correct value for the vertex. So we're going to go back, we'll fix this. This should be 5.5 negative. And so now here we'd have negative 5.5. Okay, so look and make sure if it makes sense or not. You forget a negative sign, throws off the whole answer. Right? So we got to be able to catch those things. Be careful when you're plugging in values. Okay, use the correct information, use it in there correctly, and you should be good to go. Recall how vertex forms looks. Right, this is our h value. Right, that's h. And this is our k value. The k value is the y value of the vertex. Right, the vertex is h comma k. And we can put those into our vertex form. So be aware of standard form that we've been working with here, how it relates to vertex form. If we were going to graph from here, right, we'd use that vertex and then go from there. No matter which form we're dealing with, that vertex is a key piece to what we're doing either way.